Hello fellow artists, I hope that you are doing good, and this is Adam, and this is a Blender version 5.0.1. The reason we are testing this version with the MacBook Neo, the base model, is because supposedly with 5.1 there is a lot of improvements for Metal, which is the API that Blender uses for M series of chips, and there is a lot of improvements for M series of chips in a general sense. So if you have an Apple MacBook that has M1, 2, 3, 4, 5, or even the A18 Pro, you should be getting a performance that is better than the performance that you used to have. I'm gonna go ahead and test it. So this is the Junk Shop project. Did run it through the GPU. We got an error saying the system memory simply ran out. So the GPU system memory, there is nothing left of it. And since we have only 8 GB of unified memory or RAM with this MacBook, that makes sense. However, there are a few stuff that we can tweak, and then we can see if the GPU actually can run it. So here's what I'm gonna do first. In terms of the system, here we have the Apple A18 Pro GPU with 5 cores, and that's what we are going to use to render. Now in terms of Metal ray tracing, it's on, so there is auto on and off, and then with the kernel we want the full optimization, and that is about it. So with that, what we're gonna do, we're gonna go ahead and render, and we will see just with the basic build, no changes of any kind, where we are using cycles and then GPU compute with the GPU. Are we gonna get the same error as last time, which is basically the GPU ran out of memory, or not? Well, system is out of GPU memory. I'm gonna change a few stuff. So let's go to there is performance. So with the performance, what I would like to do is for the tile size. One of the comments said the tile size is too high, change the tile size, and when you change it, it should run and it should be good. So let's change it half of that. So this is 2480. Let's set it to 1K, which is 1024, and then enter. Let's say fixed. Let's say 4. So we will see right now if it actually renders in full, and then the memory would actually go through, and it would be enough through the GPU for us to render that using the GPU. And here we are. Report error, system is out of GPU memory. So I guess that didn't help. Let's go to even lower. So this is 1024. Let's go to 512, which is half than that as well. Then I'm gonna set that to 3, and then we're gonna go ahead and render. Well, it gave us the error, system is out of GPU memory, so we are done with that. Then I'm gonna go to 256. Okay, maybe this time it would actually work. So we are updating meshes and then building and evaluating, and this is the density for smoke, and system is out of GPU memory as well. Okay, so now I'm just gonna go to 124, and if it does not run with 124, then I'm just gonna give up at least on this method, and maybe we will try something else. Okay, system is out of GPU memory as well. So in that case, basically if you are using cycles, it's just not gonna work. So let's bring it back to 2K. Now there is another way that we can go about this, even though I'm sure it's not gonna work, but we might as well try it, and that is through simplify. So this is simplify. I'm gonna enable it, and then for the texture limit, let's set it 256, and then for the subdivision, let's set it 1, and we will render. And again, system is out of GPU memory as well, and I went very low. I went 1 with the max subdivision. I'm even gonna go 0. With that, I'm just gonna go 128, and then I'm gonna go ahead and render again. Would that work? Would that going to be any difference than what we got initially? We will see. And here we go. System is out of GPU memory. I want to keep those settings just out of curiosity, and I would like to render with the CPU. So what I'm gonna do, I'm gonna go to edit and then preferences, and then through preferences we have system. I'm gonna enable the CPU and then turn off the GPU, and then with that I'm gonna go ahead and render, and then we will see. Now keep in mind, when I am rendering the first time, this is the kernel run, so the kernel run usually takes more time than it should. So whatever time we will get first, that time we should not take into consideration, as this is the kernel run, and then after that the second run would be the actual time that we will go through. For you, however, if you want to understand what unified memory is, RAM, GPU, and all of these fun stuff, I do have a video where I went into full depth about that and what it entails, and I will leave a link for you in the description and then in the comments for you to check that video as well and understand how it works. And so far it's working, and then we are getting some decent results, and we will be waiting to see when this renders in full what are the results that we are getting, and then we will compare it to the results that we got from the previous test. Now keep in mind, the previous test I kept all the settings as default and we got a time of 6 minutes.
No charge needed, I own the crowd. Vroom, shift, we move fast. Every night like this, too lit to let. Ooh, I don't sleep, I don't pop.
We are done, and this took 2 minutes and 54 seconds, and honestly, the quality is really good. I thought the quality would be worse than that. This is the kernel run, so we're gonna go ahead and render it again. This is the actual run, and whatever result we are getting right now, we will be sticking with as our new official numbers.
Yeah, all stare. Night alive, we move, we play. I'm untouchable, this in my way. Whip shine, club line, as away.
Okay, so this is done and it's denoising right now. So basically the time was 2 minutes and 58 seconds. So essentially it's in the margin of error. So the time is essentially the same. I do like the quality and I do like what I am seeing. So at least we can render it through the CPU, and then you can definitely optimize your settings and such. And then you get something similar to this. And honestly, for a device that only costs $500, this is really good. This time I'm just gonna render it. However, the render it's going to be with the default settings. So so this is done, and I have a feeling the kernel's already built, but we will definitely run it again and double check. But we got 5 minutes and 47 seconds. Let's say this is the kernel run. If this is the kernel run, this is a huge improvement, because our previous kernel run with the version 5.0 was 8 minutes, and this one is 5 minutes and 47 seconds. That's almost 2 minutes and a half. So already the performance is better. This is in case this was the kernel run. Let's say this is not the kernel run. This is actually just the normal run, because the kernel is already built from the previous runs that we have done a few moments ago. If that is the case, then this is already an improvement as well, because we went from 6 minutes to 5 minutes and 47 seconds. So that's almost an improvement of 13 seconds. I guess the claim from a Blender that 5.1 is better for metal, it's actually true. However, we're gonna go ahead and run it again one more time so we can actually get an official number, and whatever number that we are getting right now, this will be the number that we will go with, because with that the kernel has already been built, and then this is, let's say, a more of a realistic representation in real life of how much this would take time-wise.
All eyes on me when I slide through. Girls whisper soft like down as you chain cold, but my heat too loud. No charge needed.
So this is done, and our official number is 5 minutes and 37 seconds. That's definitely an improvement, and Blender, I will give it to you. Even though the improvement was actually only for GPUs, not necessarily the CPUs, but I believe since this is an SoC, basically the GPU and the CPU, they are combined together. I think that's why we are seeing some improvements. I would say in a general sense, definitely a Blender 5.1 is better than 5.0, at least with the results that we are getting. So this is the classroom project, and here simply what I'm gonna do, I'm gonna go to edit, and then from edit to preferences, and through preferences we have the CPU. I'm gonna go ahead and enable the GPU, and then we will test the GPU and then see. So right now we are in solid, and with solid, and we are using the, here it's saying the CPU, so let me change that to the GPU. And here with the GPU we're not having any issues, so I can simply move the way that I want to move. If I want to do Command V for this one, and then Command D, and then just zoom out a little bit. And by the way, no delay, working like a champ. That's in terms of solid. Let's go to material preview. So this is the material preview. It's gonna take a second for it to render everything, so we'll give it that second that it needs. Okay, here we go. Now it's compiling shaders. 35 remaining, 27, 23, 19, and you can compare that with the device that you have, with the same project, and see how fast it would, for example, compile shaders when you are using material overview. I am fascinated by it because the topology for it is amazing. And then here I can go to the Zap book, 100% recycled. No issues at all. I can move around, do whatever I need to do. I can copy stuff and then move them. Let's do this. I want to make another desk, so we're gonna simply go to that desk, and then maybe that desk probably should be right here, and then I'm gonna zoom to it, and this is good so far. This is, let's go to the rendered preview. So the rendered preview is using the GPU right now, and it's kernel optimizing as it will. So 4:45 rendering is done. Is it a bit slower? Yes, it's a bit slower than it should be, but overall it's working. Like for example, if you want to see this view, you just do that and then you wait, and then all of a sudden everything is rendered. So definitely with the GPU we are able to view things, move around in the viewport without any issues. So this is your viewport, and you can, you know, do something similar to the test that I am doing for the viewport with your device, and see, is it rendering faster, is it rendering slower. Speaking about rendering, let's go ahead and render the classroom scene and then see if that's gonna make any difference. So I'm just gonna reopen it again. First I want to make sure we have the GPU, and then after the GPU I'm gonna go ahead and render. We will see if it would render the scene with the GPU or not. If it does, that's great. If it doesn't and it run out of memory, we will simply use the CPU, and we will see how long the CPU would take. And again, you can compare that versus what you have. And if you do not have a device to compare against, then this will be your first computer. That would give you an idea of what to expect in terms of a Blender. My recommendation for people taking the MacBook Neo, if you are just learning how to use a Blender or how to use Maya, I think this machine is really good, and I recommend that you take it and simply learn with it. And when you grow and get better, then after that you can go ahead and get something else that is better. Perhaps you would jump to the MacBook Air. And if you want to know which device like is good for which case and such, again, I do have a link for you in the description, and then also in the comments for you to check out. And there is another link which probably I will leave at the end of this video, and that would be for Maya, because if you are learning Maya and you want to know how Maya is performing, spoiler alert, Maya is really good on the MacBook Neo. Well, would you look at that, this was fully rendered. Let's not jump into conclusions just yet, because I think since we have this device as CPU, it actually used the CPU instead of the GPU to render, so I forgot to change that, so I will change it. At least you know, if you want to render it with the CPU, you can, in terms of the classroom scene. And the classroom scene with the CPU takes 14 minutes and 40 seconds. I will definitely run it again, because this might be our kernel run. However, what I am simply gonna do, I'm gonna go with the GPU and then just test that really quickly. So here we have the GPU chosen, then I'm gonna run and render right away, and here we have the GPU compute. We will see if the GPU would actually finish the whole run. I really hope it would actually finish it and not give us, oh, by the way, the GPU is running out of memory. And as you can see, this comment on your monitor right now, or your mobile device if you are watching on mobile, suggested that I would try a different project, so we would have a comparison that is apples to apples, and they could be completely right, and I have taken their feedback into account. And please, if you have any feedback or suggestions or stuff that you want it to be tested, leave them in the comments below, and I will do my best to accommodate, as long as you are being a decent human being, not being a racist bigot, because I have definitely seen, sadly, some racist comment as of recent. Let's not that distract us from our main mission, which is finding out if this project, or, well, 1 minute and 37 seconds? Okay. Okay, you can tell that I am surprised. What? Let's run it again. This actually rendered. This actually freaking rendered. This actually freaking rendered using the GPU. Wow. Let's go ahead again. And please, if you have classroom scene, render it on your device using your GPU and see how much time it takes for you to render. Now, I would consider the first render as the kernel run, and this second run would be the run that we would go with, and it will be the official number that we would run with. Actually, this is rendering on the GPU on a device that costs $500 without a fan, with a mobile, like a cell phone chip on an iPhone. This is insane. And by the way, this device is not connected to power. If you look here at the top, we're actually using the battery, and the battery is about to be dead very soon. And we are rendering and doing all of what you are seeing right now on the freaking battery, and we are getting these results. Wow. Okay, so this is rendered and it took 1 minute and 37 seconds, and that's the number that we will go with. But the GPU actually can render for a project. As long as it's not the junk shop project, then you can use your GPU to actually render. So if you have a project that is similar to the classroom scene, and by the way, this classroom scene is a high quality scene, all of these objects and such being modeled, and then this whole class. So if you are just learning a Blender and your goal is to achieve something like this, like what we are seeing right now, I think this is excellent. And by the time that you get to that, probably you have clients knocking at your door already, so you might as well then upgrade to the MacBook Pro or the MacBook Air. With the MacBook Neo, you can 100% do it.
Untouchable, this is my way.